This lecture I'm going to talk about programming language. We have 3 levels of different programming languages: machine language, assembly language, and high-level language. Machine language is a set of primitive instructions built into every computer. Basically, it's machine code and it's in the binary format, as you can see down here. So it's not really readable, but it can be executed by the machine or computer CPU directly. As you can see right here, a machine code is divided into several sections. The first section we call it opcode. Opcode is the instruction. For example, like we want to move some data from some memory location to a certain register, or we want to add a certain register's content to the other register content, and then save to a third register destination register. And right here, there might be certain data and certain register they want to access, and they may have certain flag inside there. And this whole thing, from opcode to the register setup, we call it an instruction. An operand is the data or register part. And they could have direct addressing or indirect addressing by indexes. The machine code directly operate on the hardware. And then we have assembly code and the machine code with instruction set architecture that hiding the hardware from the programmers. And then your assembly code or high-level language is on top as the software. Assembly code were developed to make programming easier because the machine code is totally not readable. And so we have some symbol or some name for the assembly code. We call it instruction name. The register, not in the binary format, but we certainly use certain register name for it, like R1, R2, R3. So this one could be adding 3 14-point number together, say R1, 8 R2, 8 R3, and then store to a certain location. So this assembly code source file got assembled by assembler and then become binary machine code and got executed by the machine. And as you can see, this first IBM PC 8086 assembly language. LEA is an opcode or instruction. The difference between the opcode and instruction is the opcode is the real operation you want to do. And instruction include some flag or some address combination. That's more detail. But assembly is basically an instruction right here, and it's including all the flag setting up. And here, as you can see, is actually addressing some memory location to some register, and then you're using the register content as indirect addressing to access some memory location. And this assembly can have an assembler or emulator, and it will be operating through an operating system to the machine. So assembler is the software to convert assembly language to a machine code, and then through OS it can be executed. Emulator, on the other hand, is different. It's that you convert to machine code, but you actually run on emulator instead of the CPU. This can help you to debug the assembly code because you really run it on hardware before the hardware is fully developed, including the system bus or the I/O channel. If that is not ready, you can develop your assembly code and then run it on emulator to help you to debug. Usually this is very helpful in system software like operating system such as Windows to develop. And then debugger is a software to help you to find the error and then try out different value or combination to help you to find out the bug in the software. And this is integrated assembler and debugger. You can check the memory location by this, and your code is right here. And the register condition is right here. And then this is the 8086 instruction set architecture. Current IBM PCs M7, M5 It's totally different from this because we have a multi-thread or deep pipelining RISC machine right now. It's totally different from this old-fashioned processor 30 years ago. But we still can see that this side is data path. It's including the control unit and the logics for the data path. And this is control, and this is register file to store data. So a CPU combined of the control, data path for operations, and also for the register file for storage of memory. And then you got to access to the memory to the outside memory by the interface of the CPU. So high-level language are the English-like, easy to learn and easy to program language. For example, if we want to calculate the area of a circle, we can type variable area equals the radius times the pi. High-level language need to be compiled or interpreted, depending on the language, to the OS, and then OS executed for you. You can also compile to a certain intermediate code, such as bytecode or assembly code, and then use the assembler or some sort of virtual machine to access the OS. And here is the listing of the language from 1956 to 2004. The first language Fortran to Java JDK8. And then JDK8 actually is newer, it's a recent, not 2004. Right here you have several different languages. You have first object-oriented language, Smalltalk. You have this C++, Java thread, and you also have Perl language that is using logic programming. Lisp language is Lisp programming language. Several of them still heavily in use right now. And the last one, we show you the popularity of the language. As you can see, 2006, Java take over about 40% of the pie. And right now it's down to almost like 20% now in 2015. The reason being that some other languages pick up because they are more specialized in a certain field. So it's no longer like Java is the king for website design. A lot of language take over some share of the market right now. But Java, as a very successful web programming language, still very good language for education to learn because it has a more educational data or books or code that you can learn from than other languages so far. Thank you.